Today we're going to work on a simple regression. So I've opened SPSS and I'm going to find my data file. I'm going to maximize my screen so that I can see better. So the first three questions on this SPSS task ask about correlations of the test variables. So the easiest way to get that information is to run the Bivariate Correlation. And here I'm addressing item 1.1, correlating the tests in October to the tests in November. And it has Pearson's checked, and I can run that test, and you can check the answer. The correlation, or R, is 0.750, and the significance is we state that as P is less than 0.001. We can come back to analyze now. Correlate bivariate to address item 1.2, and we want to compare Math 1. We're going to move Math 2 back over to the April test. And it's added that correlation here. Here's Math 1 to the April test. The correlation is 0.762, a positive correlation also, I want to note. The P again is less than 0.001. And let's do our final correlation. And this time we're going to compare the November and April tests, so test 2. I'm going to remove test 1 and add test 2 and click OK. And in that final correlation, the R is 0.807, and then again the p-value is, we write that as p is less than 0.001. So the next question asks you to apply what you know about correlation. Which is the better predictor of the April test? So you can see by the correlations with the November test, which were the last two correlations that we ran, that the November test has a higher correlation than the April test, which was up here. So that is how you can determine which is a better predictor. So now that we know that the November test is the better predictor of the April test, we can run our regression. I'm going to select linear. And here, I'm going to remove these variables. We are expecting the November test to predict the April test. So April is the outcome variable, which is the dependent variable. And the November test is our independent variable. We're going to click on the statistics box and make sure we have estimates, model fit, and descriptives all checked. And we're going to run the test. And now we can answer some of the questions on the next page. You can see that 2.1 asks for the means and the standard deviations, which are stated here. You can see as we move down on the regression output, the correlation between the two, which we confirmed with our first correlation test, is here. And we're going to read this as our significance. So here we're able to calculate the coefficient of determination, which is the R squared, and you can calculate that by hand, and you can also check your work here. The next part, 2.5, has you calculate B by hand, And you can scroll down and also see B listed here. You can confirm your hand-calculated answer. 2.6, you can plug in the regression formula, which we have figured out most of the parts to. Here we have the intercept right here. And the rest of the questions you can have filled in with the information in this table. You can see the unstandardized B slope here, the standardized slope here, and in 3.1 it asks about the R squared, which is how much of the variation in the April test score we can explain with the November test score. And we can figure that out by subtracting the 65% from 100%. That is the variation that cannot be explained. And the final question, 3.3, asks about how many standard deviations are going to be predicted by the test. And here, this is the standardized coefficient beta. It refers to how many standard deviations a dependent variable will change per standard deviation increase in the predictor variable.